from 8 rectangles from -1 to 1. How wide is each rectangle? Oops. If we're going from -1 to 1. 1/4? Does everyone agree? Why is it 1/4? Good. There you have 2 units divided by 8, or you have 1 unit divided by 4. 1, 2. How do you do an Mram? In the middle. What would the x values be that I'm choosing? So this was a 1/4, a half of a 1/4. Why a half of a 1/4? It's in the middle, right? What is a half of a 1/4? An 8. So each rectangle is 1/4 of a unit wide. Does everyone agree? So that's my width. My height of my first rectangle on the right is f of 1/8. 3/8. Does everyone agree? 3/8. 5/8. And 7/8. Now, I'm lazy, so I'm going to tack a 2 in front of that. Why can I do that? Because it's the same, it's a symmetrical curve. So instead of doing, now I could do f of -1/8, f of -3/8. I get the same thing. For laziness purposes, you do have a program that will run that number for you, but again, on the AP exam, you're going to have to be able to set this up. So every time I come to one, we're going to set it up. But what is that value from the calculator? 6.65?
Yes, 6.656.
Really? Both with the doubled and everything? Weren't we at like 20 earlier? Oh wait, never, -1 to 1. We were going 0-4 yesterday. Never mind, you're right. 6 point what?
6.6.
I was not comparing apples to apples. Okay, any questions about that? Okay, so some formulas for Riemann sums. Again, if you are having to do a Riemann sum on the AP exam, you do not need a formula. You can draw a picture, but it is handy to kind of know what it is. If I have x values from x subscript 0 to x subscript n, so those are my partitions, how it's broken up, then my left rectangle approximation, now it does depend on whether you chose equal partitions or not. Do you know what I mean by that? If you chose equal partitions, you can factor out what I'm going to call delta x. What in the world would delta x be? Change in x. And I could multiply that by the heights of all the rectangles. If not, then on each rectangle you would have to do x1 minus x0 times the height. If I'm doing a left rectangle approximation, what would my first height be? F of x subscript 0. Right? I am going to go with the shortcut notation, assuming that we are choosing equal rectangles. We will not always choose equal rectangles, so just be careful about that. Plus f of x sub 1 all the way to what? Good. Why not f of x sub n? Why do you stop early? Because you're only doing the left rectangle approximation, so that makes perfect sense. Okay, so you're going to add up the heights of all the left-handed points.
What is the change in x part?
That is the x1 minus x0 is the change in x from x1 to x0. Now, what I said is I'm going to assume these are all equal partitions. So change in x is the same for all the way across. Now again, that's not always the case. So a more complex formula that is a little more this would be the more generic format. Yes, sometimes you will. F of x of n minus 1. If the partitions are not equal, we will have to multiply each one. So
the partitions
can be different sizes, yes. Now, if you're choosing them, how are you going to choose them? If you're picking, you're going to pick equal ones because it's easier, right? If you are not choosing them, you may have no choice, and I'll show you an example of that momentarily. Okay, but for the others, what's different about our RAM? I'm going to start at f of x sub 1 and go all the way to f of x sub n. Trapezoid. What would my generic formula for a trapezoid be? 1/2 change in x, which would be the height. And again, if we had multiple changes in x, we'd have to do that throughout. And what?
X to 0. 2 times f.
Good. Why 2 times f of x1?
1 foot left trapezoid.
Good, I have a left-hand trapezoid and a right trapezoid, and they're both going to get f of 1, f of x sub 1. So 2f of x sub 2, 2 times f of x sub n minus 1. But what about the last one? Only one of those. So you're going to do 2 times all the middle endpoints, but only one of the end endpoints because of the doubling on the trapezoid. So those are generic formulas for left RAM, right RAM.
On that picture, trapezoid.
So here I would have, let me use a different color so you can see it. This would look like that. And so you're doing, first one kind of looks like a rectangle, but base 1 plus base 2 on each one. So those are the generic formulas for LRAM, RRAM, and trapezoidal sum. Keep in mind, you don't need to necessarily memorize the formulas. You can always draw a quick picture and recreate. That's where people get tripped up with Riemann sums, is they think they have to memorize. Okay, I wanted to show you this one because sometimes it weirds people out when they go below the x-axis. But I'm going to show you it works out, everything works out the same. So we're going from -2 to 2. And we're doing a right rectangle approximation. So we have 4 units. We're doing 8 rectangles. So each one's a half. Everyone agree? So we have a rectangle that looks like this. And so forth. Okay? Here. But then down here, the rectangle is using a right endpoint. This rectangle to a half actually is 0 because the right endpoint is 0. And then this one down here looks like that. Okay. Everyone see how that works? Everything works out the same. It just turns out that f of 1/2 would be negative. Okay, whatever, right? It is what it is. So nothing is different on how you work the problem. So don't let it weird you out that we are dropping below the x-axis occasionally. I didn't go far enough over, did I? No, I did. That was the one tick mark. And then somewhere in here. I think that rectangle's below. And this one is definitely below. Okay. Now, again, we have rectangles that are 1/2 in width. Does everyone agree? So my first height would be f of, let's see, 1/2, 1, 3/2, or yeah, so -3/2 plus f of -1 plus f of -1/2 plus f of 0 plus f of 1/2 plus f of 1 f of 1/2. Nope, 1 1/2. Already did 1/2. And plus f of 2. So notice on the left, I left off the -2, but I did include the +2 because I'm doing right-hand endpoints. So that's the setup. Find that number in your calculator. Use the program. 16.12. 5. Any questions about that one? Okay. Uh-oh. No picture on this one. No function on this one. This could be on a calculator part of a test. They've still tied your hands to where a calculator program won't help you. So you can see how AP can be very clever on what they do. So that table shows the velocity of a model train engine moving along a track for 10 seconds. Estimate the distance traveled by the train. Estimate distance traveled. Okay. Well, if I have a velocity curve, how do I get distance? The area, right? The area would give me the distance. So I want area, and it tells me to approximate it using 5 equal subintervals, and it wants me to do it all of the ways. On an AP exam, they'd only make you do it one way. They'd just pick one. So they may say a left rectangle approximation or something like that. This one I modified so you could see all 4 options. I'm using 5 rectangles. I'm going from 0 to 10, right? So how wide is each rectangle? 2 units. So I'm going to kind of mental note that by 2 to 4, 4 to 6, right? 6 to 8, and 8 to 10. So I'm making my rectangles there. They do happen to be equal subintervals. Do we agree we're going up by 2, 2, 2? Check that every time. Check that. AP will throw some in that aren't equal subintervals. And do you see when remember earlier I said if you choose, you'll choose equal subintervals? But if they give me a table, I may not have a choice. I may have to use what I'm given.
What about 5?
4 to 6. I can't, 4 to 6. Does that make sense? So, 2 times Well, if I'm doing a left rectangle approximation, I am going to want to include the first y value, correct? So, what is the first y value? 0. Plus 22. Does everyone see where I'm getting those numbers? Any questions? So, if I were to draw a picture here, and if you have to do this, what do? You do it. At 0, I'm at 0. At 2, I'm up at 22. And so since I'm doing 5 rectangles, that's my first rectangle. Does that make sense? And then my second rectangle is from the 22. Does that make sense? Now notice I skipped the 1 because they told me 5 subintervals. If they had said 10 subintervals, I'd do 0 to 1, 1 to 2. So I took my interval and divided it by 5 to see how far over to go. Does that make sense? Okay. Notice, did I have to draw the entire picture to figure it out? No, and so you can do that on the AP exam. Just draw the part of the picture you need to go, oh, I need to use 0, 22, 5, 11, 2, and 0? Why not? It's a left-hand approximation, so 0 would be a right-handed point. So I would stop. Now on this particular problem, it's a weird one. You're going to get the same thing on left and right approximations because it's 0, but most of them it would be different. So what do we have? 33, 34, 35, 40, 80. The right rectangle approximation, I'm going to do the exact same thing, except I'm going to start at 22 and include the 0. Now again, this is a very strange problem where that happens to be the same thing.
So if you, are you multiplying by 2 because you're going by 2?
Because the width of each rectangle, if I go look at that picture, the width of each rectangle is 2 units.
And that was because you needed 5.
I think it takes to get you.
Okay. Good. That's a lot of the times that's how it's asked on AP exams. So, very common. Now, I am guessing this problem, wherever I got it from, was probably originally an Mram problem. Remember when I told you when they choose Mram problems, they make it nice for you? You remember me telling you that? How is this one nice for Mram? Because there is a midpoint, and it's easy to see. The width of the rectangles is still 2, but now I'm going to choose the 12, 10, 13. Does everyone see that? Because those would be the middle heights of the rectangles. Does that make sense? So I am guessing this AP problem that I modified years ago was probably originally an Mram. Because generally they're not going to make you do 10 rectangles. I could be wrong. 25, 35, 47 times 2, 94. Now, a lot of times people will say, well, if I do a left and a right approximation, then the average of those two is going to be the best approximation. Is that always true? Not necessarily. Now, if you're always increasing or always decreasing, then yes, an average or a trapezoidal approximation would be the best. But sometimes with a fluctuation, a midpoint approximation may be the best. So who knows? We'll talk about that in a moment. Okay, so the trapezoid, now I'm going to actually do it, but we're going to make a mental note after we're done. We're going to do 0 plus 22 times 2, correct, plus 5 times 2, plus 11 times 2, plus 2 times 2, plus 0. Would you agree if you did everything right, this better be 80? Because isn't this, those two things averaged together? A creative way to write an average. So trapezoidal approximation is the average of the left and right hand approximations. Again, you're not going to have to do all 4 on one AP problem. So a lot of people are like, well, why did I learn trapezoidal? Why don't I just average? Well, you could, but then you're having to do 2 things instead of just 1.
Isn't it supposed to be a 1? 1, 2, 3, 6, 1.
You're right. Thank you. And you get 80. If you didn't put the 1/2 there, you would not get 80. You would get 160. Okay, let's do this. Use a left rectangle approximation and a trapezoidal approximation with 5 subdivisions to approximate the distance traveled by the car. So you can tell this is common AP problem. They're going to ask it a lot. I'll give you a table. Does anyone notice anything I need to be careful about on this one? Yeah, negatives are fine.
The unit.
Good. I go from 0 to 2. Then I go from 2 to 3. Then I go from 3 to 6. Then I go from 6 to 10. And then I go from 10 to 12. Now that does happen to be 5 subdivisions, which is great, but they're not equal. That's not a big deal, but star that in your notes. Be careful. I would rather you assume they're not equal every time and then be like, oops, they're equal, than assume they're equal and get that wrong, because you will get an incorrect number. So, my first rectangle, how wide is it? If I'm doing a left-hand approximation, what is the height? Plus 1 times 20 plus
3.
So remember, a negative is a negative. It's okay. Don't let it hurt your brain. Just use it. Put it down. No big deal. Plus 4 times 50 plus 2 times 60. Notice I don't end up using the 10 because I'm doing a left-hand approximation. Someone with a calculator, well, 80 plus 20, 100. Minus 90 is 10. 330, is that what everyone got?
Miles.
Good, it would be in miles. Speaking of, let's talk about that here. Did this one give us units? These would all be in inches. Paul Grant.
So if you're doing the right side, instead of using 0, you would use what? 12.
So you would do 2 times 20 plus 1 times negative 30. Does that make sense? Because this is a rectangle from 0 to 2, but you're going to use the right-hand height on the right-hand approximation. Trapezoid, we're going to do 1/2. Now you can factor out a 1/2 if you wish, but that's all you can factor out. Everyone know what I mean by that? I'm probably not going to factor it out, just do a bunch of trapezoids. 1/2 times 2 times 40 plus 20. Now, of course, in my head when I'm working that, I'm going to go 60, right? What's going to happen to the 1/2 and the 2 on that one? This is going to be 1, so 60. I'll write that down in a minute, but let me switch colors so we can tell which one I'm on. And 1/2 times 1 times, good, 20 plus negative 30, or 20 minus 30. So this time I'm using both endpoints. Just adding up the areas of a bunch of trapezoids. Plus 1/2 times 3 times negative 30 plus 50. Plus 1/2 times 4 times 50 plus 60 plus 1/2 times 2 times 60 plus 10, which is 60. And remember, if this is AP open response, you can stop and leave it like that nasty thing, and you will get all the points. It's wonderful.
That right there, you can leave that.
Yep. You can't leave f of 0, f of 2, but you can leave numerical answers unsimplified. As big of a string of numbers as that may be.
So like,
Someone type that in.
Equation, like the trapezoid equation, it was like f of x is 0 plus 2 f of x 1. We didn't do the 2 on this one.
Why could we not do it that way on this one?
Because they're two different things.
Because we couldn't factor out that change in x, because it was different every time. So we actually had to go to geometry and just do trapezoid plus trapezoid plus trapezoid.
So on the normal one, it will be.
On the ones where you're given a function, they'll be equal subintervals, but a lot of the tables won't be. So essentially, when you come to a table problem, assume it's not equal. Just assume. If it is, oops, that'll be our.
And normally not.
You know, on AP, they like to try to trip you up with unequal subdivisions on table problems. So just assume if it's a table problem that it's unequal, and then if it happens to be equal, go, oh, cool. What was this? 375? Okay. Now let's talk about another question. As you have learned, AP loves to ask you over or under approximation questions. They do it a lot with tangent lines. Remember, you look at the concavity to see if a tangent line over or under approximates a function value. They ask that a lot with rectangle approximations. Is this an over approximation or an under approximation? So I want to look at when each one is over and when each one is under. So if we look at this one, let's talk about a right rectangle approximation. Everyone agree it's over? Okay, let's talk about right rectangle approximation here. Over? Everyone agree? What about here and here? And here? Yeah, whoops. It was. Everyone agree that's the case. So let's make a conclusion about right rectangle approximations. When is a right rectangle approximation an over approximation? And when is it an under approximation? Good. When it's increasing, it's an over approximation, and when it's decreasing, it's an under approximation. Right? So write that in your notes. RAM is an over approximation if I'm increasing, under approximation if I'm decreasing. Without drawing the pictures, what do you think about LRAM? Probably the opposite, right? LRAM, and I'll draw one of the pictures. If I am increasing, an LRAM is definitely an under approximation. Now, if you forget this, could you draw a quick picture and figure it out? Yes. However, on an AP problem, they may throw in something in the wording that said f of x is always increasing. It may be a table problem. And that's where knowing this can help you pick out an answer and say, oh, f is always increasing, so LRAM is an under approximation. Midpoint is going to be different for each one. You're going to have to draw a midpoint to find out. So it's not asked on AP very often. Let's talk about trapezoid.
That is a brief part of the interruption. Staff, we will not have a fire drill today. We'll do that tomorrow after first period. Also, students, all detentions for the rest of the year will be in Coach Holloway's room in the science building. So A and B lunch detention starting today will be in Coach Holloway's room in the science building. Thank you.
Actually sounds like a captain or pilot.
Okay, what are we noticing?
Concave up.
Ah, trapezoid's concavity. When we have a concave up function, it's an over approximation. And when we have a concave down function, it's an under approximation. So concavity affects a trapezoidal approximation. Increasing, decreasing effect left and right. Concavity affects trapezoidal. Again, if you forget that, draw a picture. However, it's good to kind of have that knowledge handy. All right, that's my last slide. Any questions? Yes. And under approximate concave down functions. Increasing and decreasing does not affect trapezoidal approximations.